Hi there folks, this video is all about naming compounds. It's lesson 4 in your booklet. So what we're going to start with is a definition of an element. And an element is a substance that consists of only one type of atom. And you can find all the elements, of course, on the periodic table. So if it appears on the periodic table, it's an element. It consists of one type of atom. So let's have a think about a compound then. So compounds consist of two or more different types of atom, okay, which have chemically combined. So you can have a sodium atom and a chlorine atom combined as a compound, but more on that in a minute. So we have two or more different elements chemically combined in a compound. So there's a task on A5, which is identifying elements and compounds. This is what it looks like. So on this table here, we have to identify whether the substance is an element or a compound. Well, sodium, for example, is on the periodic table. It exists as one type of atom, and sodium therefore is an element. So I'm going to put letter E in there. However, if we go to water, water is not found on the periodic table, so water would be classed as a compound. And indeed, if you look down here, H2O is in fact water, and you can see it's made of more than one type of atom. We've got hydrogen atoms, 2 of them, and an oxygen atom. So water would be classed as a compound. Tricky ones like this, H2, well, this is a H and another H, so 2 hydrogens, so they're the same type of atom. So because they're the same type of atom, although there's 2 of them, we would class that as an element. So we're now going to think about ionic compounds. So we've talked about an ion, an atom that has gained or lost electrons to have a full outer shell. And we've got 2 types of ions. We've got non-metal ions and we've got metal ions. Now, non-metal ions, so non-metal atoms, gain electrons to form non-metal ions. Metal atoms lose electrons, so lose negative charge to become positive ions. Now, because we've got negative and positive and they are opposite, we know that opposite charges attract. So we get this dashed line here that represents an electrostatic force, okay? A force of attraction between the 2 oppositely charged ions. And this forms something called an ionic bond, okay? So when we have 2 oppositely charged ions joined with an ionic bond, we've got an ionic compound. So let's give you an example. Now I've drawn them this way around this time because when we come to naming ionic compounds, we always put the metal ion first, followed by the non-metal ion. So the metal ion in this example is magnesium. The non-metal ion is chloride, a chloride ion. Remember that the non-metal ion changes its name. So it's chlorine that has become chloride. And very simply, you put magnesium and chloride names together to make magnesium chloride. So the name of the compound here is magnesium chloride. Another example is this one. And I've done this one because we've got the metal ion, magnesium, and oxygen combining, but we don't call it magnesium oxygen because the oxygen atom has become an ion and we now call it an oxide. So magnesium oxide is the name of this compound. Now on A6, there's some practice at naming ionic compounds. So I'll show you this page. We have an example done for us, okay? So we've got a metal ion, which is potassium, and a non-metal ion, which is chloride. And what we simply do to name the compound that these will form is put the names together, and we get potassium chloride. So potassium chloride. The same will apply to all the ones that are named. And then we come down here. And what we have to do is use our periodic table to identify these substances. So Al is aluminium. S is sulfur, but because it's an ion, look, we change its name to sulfide, and then we put the two together, aluminium sulfide. Okay. Right. In the second lesson, which is called writing ionic compounds, we get to something called chemical formula. Okay. Now, chemical formula are simply really using the symbols from the periodic table. So in this example, we've got sodium. Okay. And if you look at the periodic table, sodium is represented as Na. Now, chloride is the ion of chlorine. So we look at the periodic table for chlorine and we find that it's Cl. And the compound is these two combined. So we simply write it as NaCl. So NaCl is the chemical formula for sodium chloride. Here's another example. And in this example, we've got magnesium, which is Mg. And again, I've used the chloride ion. So I've looked up chlorine, which is Cl. So Mg and Cl come together and we end up with MgCl. However, the chemical formula this time includes this 2 down here. So why Cl2 and not just Cl? So let's take a look. So the reason is this. Now, a magnesium ion has a charge of 2 plus, but a chloride ion has a charge of just minus, which is -1. We don't write the 1. So we need 2 chloride ions to cancel the 2 plus charge of the magnesium ion. So let me show you that, look. So one magnesium ion has a 2 plus charge. One chloride ion only has a -1 charge. So we need 2 of these so that we end up with 2 minus charges to cancel out the 2 plus charge here. So we've got 1 lot of magnesium, but we've got 2 lots of chloride ions, look, with each with their -1 charge to cancel the 2 plus charge. And this ends up being the formula. So we've got 1 magnesium. It's just written as Mg, that you don't put number 1. And we've got Cl2 down here, look, because we've got 2 chloride ions to the 1 magnesium ion. Okay, now that's quite tricky, but there's a bit of practice on A7. So let me show you A7. Now, on A7, okay, what we have at the top, and this is really important, is the charge of the metal ions and the non-metal ions, okay? And if we take a look at this first one, all right, so the compound is called magnesium oxide. So the ions, we've got a magnesium ion and an oxide ion. Now, symbols of the ions, look, Mg2 plus here, we actually look up here. That's where we get that number from. O2 minus, we look up here, look, for the oxide ion, and that's where we get that number from. So the charge of each magnesium ion is +2. The charge of each oxide ion is -2. So they are the same, yeah, 2 and 2. So we're only going to need one of each because Mg2 plus and O2 minus, yeah, they will cancel each other out because they're the same size. So the ionic formula ends up actually as MgO because we've got 1 magnesium ion and one oxide ion. Okay, now we'll just have a look at this one. Potassium oxide, we have got potassium. Well, I need to look that up here, look, and it's K plus. Now that means that one potassium ion has a charge of 1 plus, but the oxide ion is already done for us, look, has a 2 minus charge. So the charge of one ion of oxide ion is -2, but of a potassium ion is only +1. Now that means that I'm going to need 2 potassium ions, each with a 1 plus charge, in order to cancel out one oxide ion with its O2 minus charge. So I'm going to need this, look. Those two, because each one has 1 plus, that's now giving us 2 plus to the O2 minus. So these two together will cancel out that 2 minus. So we end up with K2, and we write it down here, O. Okay? So that is our session on elements and compounds and ionic compound formula.